The current standard for fuel systems is dedicated PLC-based controllers, in part because of the high number of safety interlocks that are involved in good system design. We will take you through the common control strategies.
Control systems are based on PLCs, which have a history of proven reliability in industrial operating environments. The PLCs are programmable to allow for low-cost adaptation to the specific fuel system configuration required for the project. PLC controllers have a graphic user interface with a touch screen. The screen presents information in an organized way with the important operation status for the fuel system and any alarm conditions requiring immediate attention. The sequence of operations is the start of the PLC system. This is a written narrative describing how the system works, which includes responses to failed system elements. The sequence of operation may be prepared by the system design engineer or by the fuel system specialist for engineer review and approval. The fuel system will consist of equipment elements that perform a specific function and interact with other system elements. The primary elements are 1. Generator day tanks. 2. Fuel transfer pumps. 3. Tank storage and tank selection. 4. Tank fill systems. And 5. Tank filtration monitoring. The control system options are distributed or master. In a distributed control system, each equipment element has an individual controller that performs its specific function. For example, a day tank controller monitors fuel levels and maintains them within the required operation range. The distributed system controllers communicate with other system controllers via hardwired signals for critical functions and data communication links for monitoring. Typically, the system has a network interface module that allows for monitoring via a graphic interface and BMS connection. A master control system has a single controller that incorporates all system functions. The individual equipment elements are provided without onboard control. All sensors and devices connect to the master controller, which is often designed with dual PLCs and dual power feeds for redundancy. Here are the important items that are typically monitored. Day tank, active status, alarm status, high level, low level, critical low, leak, and sometimes temperature. Duplex pump, active status, alarm status, lead lag status, leak, and sometimes operating hours. Filtration polisher, active status, alarm status, filter clean, water level, leak, cycle times, and operating hours. Storage tanks, fuel volume, active status, alarm status, high level, reorder level, and low level. Tank fill systems, active status, alarm status, tank selected, 85% high warning, 90% high alarm, and 95% critical high alarm. Fuel system elements are monitored with standard industrial grade sensors. It is important that any non-metal parts be compatible with diesel fuel, so these are usually specified as Teflon or Viton. Typical sensors are fuel level, float type level switches, fuel volume, mag type transmitters or sometimes ultrasonic, temperature, RTD transmitters, leak sensors, float type switches, pump status, current sensors and motor starters, valve position, limit switches on actuated valves, flow switches, shuttle or vane type switches or thermal dispersion, pressure sensors, pressure switches or transducers.